Welcome back, folks, to the Python Made Easy series. Today is a very exciting day. We're going to talk about file reading and writing. We'll also look at file iterators, context managers. We'll consider differences having to do with data types, different operating systems. Finally, we'll have a look at one last example where we're going to pull on a lot of the stuff that we've learned and a lot of tools that we have at our disposal through Python, like loops and lists and regular expressions and type conversions. Let's get right to it. So how does Python access files? Python accesses files through what's known as a file handle. A file handle is a temporary reference assigned to a file that a user is requesting. The syntax looks like this. We have first file underscore handle. This represents our file handle. And then that equals open. That's a Python method used to create a file object. This acts as a link to a file residing on the host. Then the first argument is the file to be opened, in our case test.txt. And then an optional argument is the file processing mode, in this case R, which is the default. So if you're opening a file for reading, which is what R stands for, you really don't need to pass anything. Let's get to some core concepts about reading and writing to files. Here our objective will be to create a file, write 2 lines of text, and then close the file. So the open method returns a file object. When we use open and pass it W as an argument, we are in write mode. In this case, we're either going to create a new file with the name specified in the first argument position, in quotes, in our example, new underscore file text, if it doesn't already exist, or we'll write in a file that is already in existence. If there is a text file with that name, it will be overwritten when we use W mode. We can, of course, use A mode, processing mode. That stands for append, and in that case we are going to append what's already there in the file. Since we're passing just the file name and no associated path to that file name, this assumes that the file lives in a current working directory, the same directory where we're running our Python script from. The write method writes the string supplied as the first argument. We also include a new line character at the end. This forces each string to be on a new line. And finally, we close the file. It's important to close the file because data written is always buffered first, which means text written may not be transferred from memory right away to the disk. Closing the file or flushing it forces any buffered data to the disk. So let's examine this because the close method is important. What all does close do? It terminates the connection to the file. It releases system resources, and like we just mentioned, it flushes the buffered data from memory to the disk. We have our code in the upper left-hand section. Then we have the file that we just created, new underscore file with our 2 lines of text that we specified. And then when we run this through idle, don't expect to see any output from our shell window. It won't be there. It's all getting written to the file. And here we're going to read from the file. So the first few lines of code are what we have from the last slide. But here, starting with number 1, we open our file, new underscore file.txt, previously created. Note, we use R as our processing mode for reading files, but since it's the default, we technically don't need to include it in this case. For number 2, we use the readlines method to write text stored in our file. This reads the entire file into a list of strings. And finally, you see what gets outputted here. Note, it prints out a list. So new underscore file dot readlines is of type list. I just wanted to make sure we're aware of that because that would become important later when you try to do something more with this data. Here we'll look at 2 other ways of reading a file using Python. Way number 1. Here we're using the file object's read method into a string. When we print it like this, we get a visually pleasing output without the new line characters included, and you can see that here to the right. Way number 2 is using file iterators. Here, we use a file iterator via a for loop. Again, the R processing mode as an explicit argument is not needed as it is the default mode for reading. And you see that looks very much the same. Why here do I print like this? Line and then I take a slice and a -1. If you were to just print line, it inserts a new line character at the end of each iteration through my for loop. That would show up with each of these sentences with a space in between them. To negate that effect, we can remove the printing out of that last character of each line, which is the new line character, by doing what I did here with using string slicing. Or you could use the end equals quotes and have no space between the quotes, or you can use the line.rstrip method. It's up to you. Just a note for anybody who has called to manipulate files using Python on a Windows operating system. The Python open method accepts Unix style // for directory path names. So on Windows, any of these three options below would work instead. You could either invoke the rawstring method, as we have in the first example. You could use double backslashes, or finally you could use // Either one of those would work just fine. I'd like to make you aware of data types and working with files in Python. Data types other than strings need to be converted to a string in text mode before writing them to a file. Here we have my_num, this variable here. It's a tuple with a string and an integer, that 1042 number. We converted my_num to a string using the string method here. Once we type convert, we are now able to write the text to our file, and you see the output here. File object's position, we're going to find it, then we're going to change it. We have our code snippet in the upper left-hand corner. Getting file object's current positions using tell, and then we'll change the object's position using seek. So let's look at our text file here to the right. Our text file shows that the P in the word Python in our very first line is in position 11 or index 11. So the tell method tells us where the file object's current position is. Position 0 is at the beginning of a file. The L in the word look, the second line, would be at position 25. Note that these indexes include the new line character at the end of a line that is added automatically. We mentioned that before. The seek method changes the file object's current position. Position 0, again, beginning of the file. The new position is computed by adding an offset to a given reference point. Offset is the first argument passed, and then the reference point is the second. If no second argument's given, the reference point is 0, the beginning of the file. Notice here in our code, when we do an f.seek11, this changes the position from where f starts to output from. In this case, it now starts with the P in the word Python in the first line. That's because that is the character that is in position 11 or offset 11, and you see how it outputs here. And here we'll expose you to working with file context managers and automatic file closure. So our snippet of code here, we are using a file context manager in the form of a with statement. We have with open, the name of our file as a variable f. Why is using the with statement preferable? This allows us to use file processing code that ensures the file will be closed automatically on exit, so we no longer have to invoke the close method when we use the with statement. Here is the syntax of the with statement or the with context manager. We have with, then the expression, then an optional as variable, and then the with block. The expression should return an object. The object may also return a value that will be assigned a variable. In our case, it's the variable f. Then in the with block, we act on the object in some way. And in our case, in our code, in the body of our with block, we have a for loop. For line is our iterator, in f, and then we say print line and rstrip it. Invoke the rstrip method to take care of the new line character. It's similar output that we've seen throughout this whole course. Okay, and last slide, best slide. We're going to tackle a final exercise with files and some other things that we've learned and some other Python tools just to kind of show you what we can do with some of this stuff. So the objective here, we want to read through a file and count the number of sentences and then put each file on its own line in a clear way and indicate each sentence number in the printout statement. So let's start. We import RE to use regular expressions, and I have a suite of tutorials on regular expressions. I encourage you to take a look at that. So number 2, we create an empty list to append each of our sentences to as we traverse through our file, and we call that lines, the variable lines. In 3, we create a pattern to capture each full sentence that ends with either a period, a question mark, and is followed by at least 2 spaces. We do the 2 spaces thing because if you were to see the data that we're using, some sentences have periods embedded in them in other places, and we want to make sure that we grab full sentence and not just partial ones. In number 4, we make use of our context manager, the with statement, to open our file for reading, and we store that as the variable t. In the outside for loop here, we iterate over the file and determine which segments match our pattern stored in p. In the inside for loop that's embedded in the outside one, we iterate over those matches and we append each match to our list as we go. We have set a counter to 0. This is going to be used to both count each and every sentence and label each sentence. And in the final for loop that we have here, we print out each of our sentences stored in our list lines in such a way that we count each one and total them up. And finally, we have a print statement outside of our for loop, and this is used to retrieve the final value of count and print it out to the screen as you see in our output. So the regular expression may be new to you or complicated. It's beyond the scope of this particular class, but I encourage you, take a look if it's at all confusing to you. The 4 different regular expressions class I have from the very beginnings to more complex constructs, and I'm sure it will help you. This is just some of the wonderful things that you can do with reading files through Python and some of the other wonderful tools that Python has natively in its standard library.